Good morning. So today we'll be seeing one more test, that is a hardness test. So what is hardness? Hardness is a resistance to abrasion or scratching. So in order to determine the surface property of hardness, that is a resistance to abrasion or scratching, we are doing the hardness test. There are different types of hardness tests available. The most commonly used are the Rockwell hardness test and Vickers hardness test. Here we are going to do the Rockwell hardness test. So here you have the machine, Rockwell hardness testing machine, Rockwell cum Brinell hardness testing machine. So both the Rockwell hardness test and Brinell hardness test is performed on this machine. So what we are doing is we are selecting the load and the indenter. Indenter means specimen. This is a specimen. It's a steel specimen. So you will have specimen of different materials. So this is the specimen, and this is the indenter. The indentation is made by the indenter. Or in order to determine the hardness, we have to make an indentation onto the surface of the specimen, and that indentation is made by the indenter. So this is the indenter, and this is the specimen. So first, depending on the specimen, depending on the material of the specimen, you have to determine the indenter, and that is given on this chart on the side of the machine. So here we are doing test on two specimens, steel and brass. So for steel, you can see that the indenter used is a diamond indenter. So you have to use a diamond indenter, and the load to be applied is 150 kilogram force, and the scale reading that is to be taken is the C scale reading, which is given by the black dial on the machine that you can see. So here the specimen selected is steel, and the diamond indenter is fixed onto the machine. Then here this is the dial. On this dial we have to select the C scale, which is the black scale. Okay. Then the load applied. Load is applied over here. The load applied is to be selected. The load applied is to be selected. So for this test, for steel specimen, the load to be applied is 100 kilogram force, and this is called the major load. Major load. That will be 100 kilogram force. Then depending on the specimen, that will change. So here you have another specimen, which is a brass specimen. So for brass specimen, the indenter used is a ball indenter. Ball indenter. So this is a ball indenter. So when you are doing the test on the brass specimen, what do you have to do? So first, to do the test, you have selected the specimen. It's a steel specimen. For the steel specimen, the indenter used is the diamond indenter, and the diamond indenter is placed over here, placed in the machine. And then, so here the major load is 100 kilogram force. This is lever in the disengaged position, and when the load is to be applied, the lever has to move to the clockwise direction. So the load is selected, major load is selected, 100 kilogram force. When selecting the load, lever should be in the disengaged position. So I have selected the load, this 100 kilogram force. You can select the load by changing this. Now for this test, it is 100 kilogram force. Then that is selected. Now here the specimen is placed, and the indenter is placed in the machine. Then we have to give a minor load. So minor load is given by moving this head towards the top. So when the specimen is just touched by the indenter, you can see that this dial, the inner dial should reach the point 3, should reach that red point. Then the minor load is given. So that is given by moving this upwards. Now you can see the minor load is given. Minor load is given till that inside dial reaches the red position. Okay. Now the initial load is, minor load is given. Now we are going to start the test. Now we have already seen that the specimen is steel, the indenter required is already placed and the minor load is given. Indenter is a diamond indenter. Then we have to read the black dial and the load to be applied is 100 kilogram force. Now since a minor load is given, I am applying the major load. Major load is to be applied for 10 seconds. I am applying the load. Then you can see that this dial moves. So that means indentation is made into the specimen. Now it has stopped. That's a time for the application of load. Now you remove the load, then the dial will return to will move to a position, will move backwards to a position, and there you can see this is the position. So the C scale reading gives a value of 36. So that will be the Rockwell hardness value for this specimen. Now we can do this test for the next specimen, that is a brass specimen also by. So when doing the test for the brass specimen, the changes to be made is to be noted from this chart. So for brass, which is a copper alloy, so for copper alloys, the scale to be used is a B scale. There, for the previous test, it was the C scale which was used. Now for the test, for the hardness test on brass, you have to use the B scale. The indenter is to be a ball indenter, and the load applied is 100 kilogram force. Test on the brass specimen. The indenter used is a ball indenter. The ball indenter is placed in the machine. Then the specimen is placed. Now we are giving the minor load. So that means the indenter has to just touch the specimen and the minor load is given. So you can see how the minor load is given. The minor load is given till the inner dial reaches the red point. Now for this test, the red dial is to be used. It means the B scale. B scale is given by the red dial. So that is to be used. Then 100 kilogram force is to be applied. So we selected that particular load. When already it is selected, now we are going to apply the load. When the load is applied, you can see the dial will move. It will reach a position. Then you can disengage the. Then it has reached to a particular position. You note the reading. Now we have seen how to do the Rockwell hardness test using the Rockwell hardness testing machine. So the things were given on the chart. Use the chart and give the required, use the required dial and give the required major load. Then you can note the reading on the given dials, which will be the Rockwell hardness number. So Rockwell hardness number expresses the hardness in a quantitative term. Then next test is the Brinell hardness test. For Brinell hardness test also we are making use of the same machine, but the difference is that we are making use of a ball indenter. Whatever be the specimen, we are making use of a ball indenter. The reason is the diamond indenter will not give a proper indentation in this case, because here we require a circular indentation which is given by the ball indenter. And then that indentation is observed by using a microscope. So first the specimen is placed, whether steel or brass it is placed, then we are using the ball indenter, and using the ball indenter the minor load is initially given, and then we are applying the major load, and the indentation will be caused by the indenter, and later we remove the specimen and measure the diameter of that indentation made by the ball indenter by using a microscope, and based on that diameter we are calculating the Brinell hardness number by using the equation given. Okay.